Welcome. In this tutorial we will be using the elimination method to solve a system of linear equations. This is example number 4. Let's start by labeling the equations, equation 1 and equation 2. Next we will inspect the equations to see if there is an easy way to eliminate one of the variables. Let's start by looking at the x terms. Is there an integer by which you can multiply the smaller x term to make it look like the larger x term? The answer is yes. We can multiply 2x by 4 to make it look like 8x in the lower term. So let's do that. Let's multiply the top equation by 4. Now if we multiply the entire equation by 4, we need to multiply each term by 4. So 2x times 4 gives us 8x plus 3y times 4 gives us plus 12y plus 1 times 4 is plus 4 equals 0 times 4 is 0. This is a new equation, so let's label it as equation 3. As for the bottom equation, we're just going to slide it over so that the x terms and the y terms line up, as well as the constants. Now this is not a new equation. In fact, it's still equation 2. We've just moved it over. Now let's take a look. We have 8x in the top equation and 8x in the bottom equation, which means if we add these two, they will not be eliminated because we'll end up with 16x. So instead of adding these two equations, we are going to subtract. In fact, we're going to subtract, so that's 3 minus 2. So let's take a look. 8x minus 8x is 0, which means the x terms have been eliminated. 12y minus 7y is 5y. Plus 4 minus negative 11. Plus 4 minus negative 11. Maybe we should write that part down. Plus 4 minus negative 11 is equal to 0. Now, let's take a look at this equation. This equation does not have an x variable because the x variable has been eliminated. So let's solve for y by simplifying the equation first. Minus a negative becomes a plus 11, and collecting the constant-like terms, plus 4 plus 11 becomes plus 15. And to isolate y, let's subtract 15 from both sides so that it no longer is on the left side, with just 5y remaining, which is equal to 0 minus 15, which is negative 15. To isolate y, divide both sides by 5. Remember, 5 divided by 5 is 1, and 1 times y is just y, which is equal to, in this case, negative 15 divided by 5, which is negative 3. This is the y coordinate to the solution that we're looking for. All we need now is the x coordinate. To get the x coordinate, we are going to have to substitute this answer for y, which is negative 3, into one of the initial equations, either number 1 or 2. Now I'm going to select equation 1 because the numbers seem to be smaller, and that's always nice to have. So I'm just going to copy the equation out so I don't make a mistake, and then I'm going to replace the y with negative 3. So I have 2x plus 3 times negative 3. Now I have an equation with just x, which then I can solve for. simplifying, plus 3 times negative 3 is minus 9. Minus 9 plus 1 is negative, or minus 8. To isolate x, let's add 8 to both sides so that the 8's are gone. I get 2x is equal to 0 plus 8 is 8. Divided by 2 both sides, I'm left with x equals 8 divided by 2, which is 4. Which leaves us with the conclusion that the solution is the ordered pair of x first, which is 4, then the y, which is negative 3. And that is the answer to this question.